Today we are going to see about the natural products. In the natural products, the important topics are alkaloids, carotenoids, porphyrins, vitamins and insect pheromones. In that we are going to see today is insect pheromones. In that we are seeing grandisol, bombicol, German cockroach, dispellure, brevicomin and farinol. First, we'll see the definitions for the insect pheromones. What is the definition? Pheromones are chemicals used by insects and animals to communicate with each other. They produce these chemical signals to help or to attract mates, to find food and to warn others from predators. This is the proper definition for pheromone or insect pheromone. Next, we'll see the functions of pheromones. What are the functions for these pheromones? Means these pheromones are chemical signals that carries information between individuals within a species, and it helps to induce a physiological or behavioral responses in each and every receiving individuals. And these pheromones plays a crucial role in mate finding and finding foods and other some interactions among animals. Next point is the pheromones are all widespread among insects and vertebrates. These chemicals are secreted by a special gland, may be secreted by a special gland or may incorporated in other substances, may incorporated in other substances like urine also. Through the urine also they can release pheromones, and through that pheromones also the glands may work. Means the pheromones may work in their processes through this urine also. And these are also used by, means these pheromones also used by some fungus and algae as an attractant in their reproductions. Next is the control. Pheromones are also used in insect control. Why? And what are the methods? In what methods these pheromones are used as an insect control? The first is insect pheromones are essential components of monitoring and management tools targeting pests of agricultural crops. Methods. What are the methods? In what methods these pheromones are used as an insect control? First is mating disruption. Next, mass trapping. Next, attract and kill. Next is push and pull. These methods are used for the insect controls, and these are the methods they are used for the insect control, and these are a direct pest control strategies. Only these four are the direct pest control strategies. Next, we will see what is the classification, how these insect pheromones or pheromones, how they classified, and what are the classifications. We'll see that also. The next we are going to see is classification. What are the classifications of pheromones? Depending on their activity, pheromones are classified into four types. That is sex pheromone or attractant pheromone, alarm pheromone, aggregating pheromone, and trial making pheromones. We'll see one by one with an example. Now we'll see the grandisol, the synthesis of grandisol. Grandisol is a type of sex pheromone which will be seen in male cotton ball weevil. It's a name of an insect, and in this synthesis we are going to do the alkylation and 2+2 cycloaddition. And this grandisol is a natural grandisol which is in dextrorotatory. Levograndisol is an artificial one, but only the natural dextrorotatory grandisol we need. So we'll see how to prepare, how to synthesize the dextrorotatory grandisol. First, we'll take a substrate which contains ketone group, alkene group in a hexane ring and with a methyl substituent. Then we are reacting this substrate with ethylene. In this, we can able to see dienophile and diene. So whenever there is a dienophile and diene is going to recur, there will be an cycloaddition. So here 2+2 cycloaddition is taking place in photochemical condition. And next we will get a product with a cyclohexanone, which is attached with cyclobutane ring, and then it's getting reacted with NBS and Li2O3. NBS is nothing but N-bromosuccinimide. It's a reducing agent. It's reducing to hydrogen, so we are getting a pi bond over there. And next, it's reacting with CH3Cl, methyl lithium, and NH4Cl in the presence of H2O. Hydrolysis is taking place, and because of the hydrolysis, ketone is converted into OH and H getting attached with the same carbon. And then this compound is getting oxidized in the presence of KMNO4 and NaIO4. KMNO4, this is a best and good oxidizing agent, which is a non-selective agent. But why we are taking this KMNO4 means, here this KMNO4 is an oxidizing agent. It is oxidizing a double bond. The pi bond, it's oxidizing into a vicinal diol. Then the vicinal diol is breaking and making a carboxylic acid and ketone group. Then after that, Wittig reaction takes place. Through that Wittig reaction, what is meant by Wittig reaction means, Wittig reaction will help us to make a alkane from ketone into alkane. Then the product, then this compound is undergo reduction, that is in the presence of LiAlH4, lithium aluminium hydride, in the presence of H3O plus hydronium ion. This is reducing C11O into CH2. That is, first CH3O will react with the ketone, and then the reducing will happen through the reducing reagent. The red color compound, this is a final product, which is a positive, that is dextrorotatory grandisol, which is a naturally occurring grandisol. We can able to prepare this grandisol through this synthesis also. So next we'll see the bombicol. Next we are seeing is bombicol. This bombicol is also a sex hormone. It's also an example for a sex hormone, and this pheromone makes the wings to flutter. These pheromones we can see in a silkworm, which is an adult male silkworm, and through that antenna, the male silkworm's antenna, it used to secrete the bombicol sex pheromone, which makes the wings to flutter. And this is the actual structure of bombicol, and we'll see the synthesis of bombicol now. Okay, now we'll see the synthesis of bombicol. Before that, we saw what is insect pheromones, what is the definition, what are the classification, what are the functions for insect pheromones, and how they are classified, and we saw the synthesis of grandisol also. And secondly, we are going to see the synthesis of bombicol, which is also a sex pheromone. Okay, this we will come to know. This we will see in silk moth, the male silk moth, the adult silk moth. So for synthesis of bombicol, first we need to take a substrate. In this substrate, what we have an C5H11 alkane, which is attached with an epoxide, and that epoxide is again attached with the alkane group. Again that alkane group is attached with alkene, then the acidic group. So this is a substrate which have alkane, epoxide, and carboxylic acid. All these functional groups are containing only the same single substrate. So if we react this substrate with KOH and MEOH, we will get OH here and here. That is a above and below plane, that you know very well, that I think so. This is an above plane, which is a dark line, and this is a dotted line, which is a below plane. This epoxide will be hydrolyzed, and we will get an above and below plane of the OH hydroxyl group. And then when this compound is reacting with NaIO4, the whole C5H11 and CHO, the aldehyde group, the alkaloid, the group will be eliminated, and then we will get a ketone group here. Then this full compound will react again with this KOH, MEOH and it will try to reduce the carbon atom, means not a carbon atom, carbon chain, a linear chain, it will try to reduce, and it reduced a CH2 molecule here. It reduced a CH2 molecule here. See, the CH2 molecule is disappeared, nothing but this CH2 molecule is attached with this CH2 molecule. The 7 count is converted into an 8 count. So the next, again this product, not a product, this compound is reacting a reaction that is known as Wittig reaction. Where and all the Wittig reactions takes place, there will be a reagent. Through that we will come to know this is a Wittig reaction. The reagent is N-butyl lithium, NBULI, and PPH3, which is double bonded with C4H8. This C4H8 is abstracting by this ketone group. C3H7 is abstracted by this ketone group, and CHO group is abstracted by this Wittig reagent. So from this what we took, C3H7 is taken by this ketone group, we got a 2 alkene instead of 1 ketone and 1 alkene group, we got 2 alkene, and this rest and all same. Then this compound is reacting with an reducing agent. A common well-known reducing agent is lithium aluminum anhydride, LiAlH4. What is the function of this reducing reagent? This reducing reagent, one, it will abstract an hydrogen, or else it will reduce an hydrogen. So, or else it will reduce a oxygen. Here it abstracted, or it converted CO group into CH2 group. Here the CO, everything else are same. This CO group, C double bond O, the acid, how we will write the acid? C double bond O, OH. This CO group is converted into CH2OH. This is the function for LiAlH4, lithium aluminum hydride. C double bond O in carboxylic acid group, which is reduced to CH2. So this counting of 8 moles of CH2 is converted into 9 moles of CH2. So this is the final product of bombicol. This is a bombicol structure. So finally we synthesis the synthesis of bombicol. This is a bombicol structure. Then we completed this grandisol. In this one we are seeing, in this we completed grandisol and bombicol. Now we have to see the rest of the thing. So we'll see now this one, brevicomin. So next the topic we are going to see is brevicomin. This brevicomin is an example for aggregating pheromone. Aggregating pheromone. And this brevicomin pheromone we can see in, not even anhydride, we can able to see in the beetle. Okay, that beetle name is western pine beetle. Western pine beetle. And this brevicomin, there are two isomers. There are isomers of brevicomin. That is, one is exobervicomin, one is endobervicomin. Exobervicomin. The another one is endobervicomin. This exobervicomin is biologically active and optically active. This endobervicomin is biologically and optically inactive. This endobervicomin is optically and biologically inactive in nature. And this exoberbicomin is active in nature and biologically active, optically active also. This is optically active, biologically active in nature. So from this what we will know? So this endoberbicomin is optically and biologically inactive. This exoberbicomin is optically active and biologically active. So what we should prepare? We should synthesize only the biologically active exoberbicomin. So we'll see the synthesis of exoberbicomin. We'll see the synthesis of exoberbicomin. We'll see the synthesis of exoberbicomin. First, the substrate what we are taking. The substrate, it is an aliphatic in nature. It has ketone group and alkyl group. So we can guess aliphatic in nature. It has alkyl group and also a ketone group. So this is going to react with vicinal diol. This is going to react with vicinal diol. What is meant by vicinal diol means two alcohol group which is attached with an adjacent carbon atoms. A geminal diol means two hydroxyl group which is attached with the same carbon atom. So this is a vicinal diol in the presence of H plus an acidic medium. So what we will get? This is same. The difference we are getting in this ketone group. This ketone group is differing. So okay, what is differing in this? H plus and H plus is reacting in an acidic medium, and this 2H, this O is leaving as a water molecule minus H2O. Then this vicinal diol is attached with the same carbon. The next is this product, not a product, this molecule is reacting with CH triple bonded C bond C2H5 Na metal and NH3 liquid. It's reacting with this. What we will get? This is gets attached in the place of alkyl group, not an alkyl group, halo groups. This whole molecule will be getting attached with the place of halo group. The halo group will be eliminated. The halo group will be eliminated as HBr. So if the HBr is getting eliminated, the remaining will be acetus. This is getting eliminated. Again, what we will get? CH to CH3. CH, C. Here one carbon is there. C, CH, CH to CH3. So this gets attached, and then this is getting. Wait, I will edit this one. This is getting reduced in the presence of hydrogen nickel. H2 nickel in the presence of OAC. It's getting reduced. How it's getting reduced? getting reduced. Like this means here what reduced? The triple bonded carbon atom is reduced to a double bonded carbon atom. Then this is reacting with peracid, aromatic peracid. And in this aromatic peracid, in its meta position, the alkyl group is also here. So what is the aromatic peracid will do? Peracid, actually this peracid is an oxidizing agent, good oxidizing agent. So what will oxidize? This will oxidize the alkene into a double bond into an alcohol. KMnO4 will oxidize this alkene into vicinal diol. This peracid will oxidize this alkene into epoxide. So what we will get? This oxidize the double bonded into an epoxide. So this is cis and trans epoxide. See, one is cis and one is trans epoxide. Cis trans isomers in the same molecule. Then they will leave this for separation. They will leave this for separation from HPLC, that is a high resolution liquid chromatography, and we will get cis isomer, only the cis isomer, because we want the exoberbicomin, not the endoberbicomin. So here in this is an intermediate, we got both the exo and endo we will get. If this is going to react further, we will get both the exo and endoberbicomin, which we don't want. So here only we are separating that and we are getting the cis isomer. And again this is reacting with an acidic medium. Then we are getting an intermediate like a product. This is an intermediate we got. So this is the pre-final compound or molecule. Then further it's reacting for a ketal formation. So I'll erase this because the place, hope you will understand. Okay, this is want to form a ketal formation. Then we are getting the final product, which is an exoberbicomin. What is the structure of it? You can guess the structures during the synthesis process also. So a pentane ring which is involved with 2 oxygen and one alkyl group, that is CH3 group. Not like this. I will draw it clearly. This one we will get this is exoberbicomin. This is the final structure which we got now. We saw the synthesis and we saw how the structure is forming through what are the method. What are we did here? We did the epoxide formation, vicinal diol we formed first, and we did the substitution reaction, and the elimination of HBr, and we did the reduction with the help of reducing reagents, and we did the oxidation with the oxidizing reagent, and we got both the exo and endo product we will get if we continue further from this molecule. So we took a support from HPLC method, this and high resolution liquid chromatography method. Through this we got 1DSS isomer which we wants to get, and then we acidified it and we got ketone with an alcoholic group, and we did a ketone formation. So we got a structure like this, from aliphatic to aromatic, not an aromatic, from aliphatic to we got a cyclic structure, with a stereochemistry. So this is the specificity. Through all these methods we did reduction, oxidizing, we used reducing agent, oxidizing agent, everything we used. So what is the difference? I said this is the exo brevicomin. What is the endo brevicomin then? Through this you can find out. Why? Because I showed the stereochemistry also here, right? What is the exo and endo brevicomin? So this is exo, this is endo, this is biologically active, this is biologically inactive. So we synthesize the biologically active exo brevicomin. So we finish this also, brevicomin. Next we are going to see this one, this paleo.